Let's discuss another problem. Let's say op-amp is there with non-inverting terminal connected to V1 and the inverting terminal is connected and feedback to with output with the R2, and one R1 is connected here with the grounded. Earlier it was, and now we have taken these two things together and we just try to add join these R1 with this here. And these two feedback also we have connected through R3. Let us say we have got this type of circuit there. In this particular case, how to do that? So what we have did, since we have V1 is connected to the non-inverting terminal, so this V1 at the negative is also the same V1 potential. So the potential over here is V1, which is reflected here is V1. Similarly, VA is written here as it is, and here the V2 is a potential at this minus point, and that way this potential is also V2. So we have written here V2. Sorry. So if we take the node analysis at node 1, so we can say V1 minus V0 by R2, V1 minus VA by R1, and V1 minus V2 by R3 is equal to 0. And then we take the V1 all the elements one side, then V2 its element in one side, then VA its element R1 in one side, and V0 to the other side with R2 divided. Similarly, if we write that node 2 here, node 2 again we write, so node 2 if you write the node analysis, so V2 minus 0 by R1, V2 minus VA, V2 minus VA, it's immediate node, V2 minus VA by R2, V2 minus V1 by R3, we write this equation, and again we take V2 all the elements together, where it is that V2 1 by R3, here is the V2 all the elements here, and here V1 and its element, V1 is minus 1 by R3, and again VA terminal is VA by R2 is equal to 0. Now if we want to find something like out of it, so its terms are not getting eliminated because of these different voltages. So let us say 1 minus 2 if we do, if we do 1 and minus 2, so it is like V1 and V2 are getting, if we say V1 minus V2 and all the elements are same, so we can rewrite this. Similarly here V2 and V1 is there, that also gives, this side is subtracted, equation 2 is subtracted from 1, so this will be plus V1. So V1 minus V2 1 by R3 sorry, and again we have a VA here 1 by R2 will be positive, so 1 by R2 minus 1 by R1, then V is equal to V2 by V0 by R2. So if you find what is a V0, V0 is V1 minus V2 taken common, it is 1 by R1 plus 1 by R2 plus 2 by R3, this is the entire thing there, multiply with V1 minus V2 plus VA 1 by R2 minus 1 by R1. So that is how we get the V0, R2 can multiply it over here and here, and we can get V0. But what if we find as the VA is a terminal, also voltage is also there, and we want to remove this VA from this thing. So what is the problem we find as we are not able to remove it? Okay, so what we will do is if this R2 and R1 would have been same, then instead of like this R2, if we have this is R1 and which is same as R1, probably this would have eliminated. We will see this, and if that is R1, we will take this is R2, okay, and we will have this pattern over here, and let's see what is the change in the equation if this is a situation like this. If that is the case, so we will have some of the things we will remove it, that is this will be R1 and this will be R2, rest of the things remain as it is. So if our node 1 will have all the things will be same as it is, so we'll have the node 1 equation remain same because node 1 doesn't have this two R1 and R2 parameter of this color change right now, but node 2 will have the difference. So instead of this, so we have here R2 and VA minus V2 minus VA divided by R1, and this will be remain like that. So this will be okay. So we can rewrite this as V1 by R3, correct? V2, all the terms will be same. Here also it will be correct because just interchanging, otherwise the things will same. And VA, this will be here instead of R2, this will be R1, correct? So we got a change in the equation to only one change is that VA is divided by R1, rest of the there's no change, other changes there. So now if we subtract this equation 2 from equation 1, in that particular case we'll have this VA and VA, these two things will get cancelled out, so we'll have this terminal equals to 0. Rest we will not have any changes anywhere. As you can see that the things, there is no changes over here. So only one thing, these two things are get out from the circuit, and what we have is this thing is available. So we have got only terminal what is available with us is this only, right? This is the output we get, and which implies that V0 is equal to, we can have V1 minus V2, and we can multiply here R2 by R1, or we can later write, we can write in this systematically 1 plus R2 by R1 plus 2 R2 by R3. This is what is the answer, what we get, the value of the V0 if the circuit we change the parameter like this. So this is what is one different kind of circuit that we have gone through, that will help us to understand that why this R1 need to be same as this R1 and this R2 need to be same. So we get V0 as a subtraction of these two terms here. So we get here V0 as V1 minus V2, and with some parameters, elements. So we can have different three, more than that value with some multiplication here. So thank you. In the next videos we'll have another discussion with another problem.